Bismillah ar-Rahman rahim. In the name of God, the most merciful, the most gracious. Dear students, today we talk about the Bresenham's line algorithm derivation. We have already seen the DD algorithm. Okay, now we come to the next algorithm, which was developed by the Jack Bresenham, who worked for 27 years for the IBM, and then later in 1960s, basically he developed this algorithm, okay, which is a raster line generating algorithm, uh, where we use the integer calculations, okay, and which are very accurate and efficient. Then DDA, there is no gaps, lines are little better than the DDA. It also is known as the midpoint line algorithm, so we discussed it in the last lecture also. So if you try to draw a line on a pixel based structure where we have a display screens made of the pixels, these circular pixels, then we may have a tie between the two pixels. Say for example, this is let me screen draw it. Say we have a line going from, say these are my pixels, and but you should remember there's no gap in the pixel at all. But if there is a line which is going from, we say the center, say for example here is the center of this pixel and this is the center of this pixel, and we have a line which is going from, say for example here, okay. Now question is, should I color this pixel or should I color this pixel, right? In that scenario we see which is, say this was the that center of the pixel is another center of the pixel, and the line is going somewhere which is half off in that pixel, maybe, but it may go from the both pixels. So we have to choose which pixel, should we choose the upper pixel or the lower pixel. For example here, if we say if the angle is less than 45 degree and delta x is greater than, delta x is more than the delta y, so the slope is going to be the less than 1, the slope m is less than 1. In that scenario we know the x all the time increments, but y, should I take this y or should I take this y? It depends upon the line which is closer to that, the center of the pixel at the top and the bottom. For example, this is my, say, xk and yk, okay. At a kth point, I'm talking, say this time k is here 3, right? 2 3 4. So I'm talking of, this is the xk is 3, yk is also 3, okay. uh, but y is x is on this side, x is 2 and y is 3. So x of k is 2 and y of k is 3, it is 3. Now when I move on to the next, should I this line is going like this, should I color this pixel or should I color this pixel? I cannot draw exactly this point, which is why the line is, okay. Why? Because that's the vector graphics. We have pixels, we have to choose from top and bottom some pixel which will be closer to this exact point, okay. So for this exact point, say this is its y, the exact y of a line from the slope, which we get from the slope y equals to mx plus c, okay. Now the c, or you sometimes write b, whatever you like, that is your x-intercept or y-intercept. We know that, we have discussed the y-intercept and all that. uh, and now my point is that this is the exact y. So what is, if I choose this pixel, that means I'm incrementing x to x plus 1, okay, but I'm keeping y to the yk only, because this is the yk is 3, yk is equal to 3, so I'm not incrementing it and keeping it the same yk. The y I'm not incrementing because I'm on the same line, because y go from here to up. This is y2, y3, y4, y5. I'm keeping for this pixel, and for this pixel y remains same, but this is xk, so this is xk plus 1. So either I have to use xk plus 1 and y is same as yk, but or I increment the x So what is the dimension of this pixel? This is x has changed to the x plus 1, so from 2 it has gone to the 3, and y has gone from 3 to 4. So x has also changed from x of k to x of k plus 1, and y has also changed to y of k plus 1. Whatever the y of k was, that is 3. 3 plus 1 is 4. So for this guy, it is 3x 4y. 3 4. For this pixel, the original pixel which where from we started, its xk was, x was 2, y was 3. So for this one it was 2 3. Okay, now should it go to 2 next pixel where you increment the x 2 to 3 and keep y same as 3? Okay, or you go to 3 4, you increment x as well as y. So that means if for this point, let me clear the clutter first. One second. So what I'm telling, technically telling now is that if this is x of k, okay, this is x of k and y of k for this point, where y is 3 and x is from this side 2, okay, because y goes from this side and x goes from this side, x is 2, y is 3, so we have a 2 3 for this one point. So x of k, y of k, should I increment? X has to increment all the time if you are talking about uh, slope is less than 1, that means delta x is greater than delta y. Okay, in that scenario I'm saying that means you have to change either this pixel or you have to choose this pixel between these two pixels. So that means you can go from x of k to x of k plus 1, you have to go that all the time. For this pixel it is also x of k plus 1, for this pixel also x of k plus 1. That means if x of k was 2, for this one it is x of k plus 1 is 3, for this one also it is 3, right? Because we have moved from here to here and from here to here, the x increments, that's x of k plus 1. But for this one, the y of k, y remains same as y of k, because this one has a y of k which is 3. For this one it stays as y of k. So that means for this one it is x of k plus 1, but y is same as y of k. But if I choose the top pixel, then x will become x of k plus 1. That is, if x was 2, it becomes 3. But what is the y here? Y is y of k plus 1. So that means technically x becomes x is equal to x of k plus 1, whatever the x of k was, that becomes x of k plus 1. But y either goes to y of k plus 1 or it stays at y of k, right? So that means if you see this line and you have to decide between this pixel, between the pixels, you have to choose, because you go to the next, okay, so should you draw this pixel or should you draw this pixel? Now again you go to the next, x, should you draw this pixel or should you draw this pixel, and so on. The decision, you have to take a decision which pixel actually you are going to draw, right? So that's what I'm saying. Okay, you have to take a decision. So you need some kind of a computation. Okay, here as you could see, you have changed from x1 y1 to x of k y of this is x of 1 y of 1 to x of whatever you say, x of 2 to y of 2. Then you, when you draw a line, you have to take decisions which pixel you have to take. Should you take this pixel, or should you take this pixel, or you should take this pixel, and so on. So you have to take all the time decisions which pixels you are going to draw. So that pixel decision depends on something. Okay, so what I am saying is, so we need a decision parameter to decide which pixel to choose. That is, for this for the original pixel we have x as x of k and y of k at that moment, whatever the k was, that is 3 here for the y and 2 here for the x. Okay, now either you go to this pixel or you go to this pixel. If you choose the lower pixel, then x all the time increases but y doesn't increase. But for the top pixel, x increases, y also increases. but this is for when delta x is greater than delta y, and you are all the time incrementing x, and for y you have to take decision. But if it is delta x is less than delta y, that means for all those which are greater than 45 degree, all those lines which are greater than 45, this 45 degree, for all those lines, okay, delta y is greater than delta x because it has gone more to the y. Here inverse of this happens. Delta y, y of k all the time increases. For this case, y of k all the time becomes y of k plus 1. Okay, but for x you have to take decision. Should you take x of k only, or you should take x of k plus 1? It is to be decided. And if it is 45 degree, then you have to take no decision. X also increments, y also increments. All the time x becomes x of k plus 1 and y becomes y of k plus 1. Okay, if it is 45 degree, then you don't have to take any decision, because all the time x increments, y increments in the same amounts. Nice. Now these are the advantages of DDA, because it was a little faster. Okay, because here what we do is we actually use in Bresenham the line formula, but we didn't use in the DDA. Okay, uh, and we used the x increment and y increment there, and we didn't use multiplication operation and all that. We use x inc and y inc, but later on that lead us to the disadvantages, because that is having the floating point operation for the delta x and delta y. We know that we have to calculate x increment as delta x by k, and y increment as delta y by k. Now these are the floating point operations. Then you have to do the round off. There are the errors, and you have to calculate all the time the round offs and all. It becomes very, very slow. So we say don't do that, and don't have the floating point operations which are very slower. So we need to now derive, because what we want to derive is we want a decision variable. We want to calculate the decision variables. Depending upon that decision variable, we decide should we take the lower pixel or should we take the upper pixel. This is my upper pixel, this is my lower pixel, and this is the actual line where the y, this is the actual y, which is which the line has. But on a raster graphics, we know we can have the pixels, so either I have to choose this pixel or that pixel. So what we do is, if this is the line and this is that exact y, okay, then we see, say this is the d upper, or we call it as d2, and this is d lower, or usually we call it as d1. Okay, I have to see who is smaller. If d1 is smaller, that means this line is closer to this pixel, then I will choose this pixel, lower pixel. If d2 is smaller, there is distance from the actual center of the pixel, the upper pixel, and the actual line, okay, if that is smaller, that means this line is closer to this pixel, then I should choose this pixel, not the lower one. I should choose the upper pixel. This is the exact y the line has. Okay, and this is y of k plus 1. If I choose this pixel, then y will become y of k plus 1. If I do not choose the upper, I choose the lower pixel, then y will stay as y of k. But for the x, okay, now for this pixel, say for example we have started from this pixel, and this was the initial x of k. Now for this is my x of k. Now x has to increment to become x of k plus 1. Either I choose the top or the lower pixel. In both cases, x becomes x of k plus 1. Okay, but y either stays as y of k, that means I am choosing lower pixel, or it goes from to the y of k plus 1, that means I'm choosing the top pixel. Right? It's very simple. You have to watch the previous vids and all to get it clearly. So we are talking right now for the slope with m is less than 1. When the slope is less than 1, what does that mean? Slope is less than 1. That means delta x is greater than delta y. Okay, that is why slope is greater than less than 1, because slope m we know is equal to delta y divided by delta x. If delta x is greater, then the numerator denominator is more. That means this slope is gonna be the less than 1. That means our line is not more than 45, but it's less than 45 degrees somewhere. that means it's moving more towards x, okay, than towards y. So that means x all the time has to increment, and decision is to be taken on y. Should I increment y or should I not? Should I take the top pixel or should I take the bottom pixel, right? So decision is to be taken on the basis of the y, who is nearest to the actual line path, okay? And x all the time becomes x of k plus 1. So if we have a position of the pixel of x of k, y of k, the next pixel will either be x of k plus 1, all the time x will increment, but y will stay as y of k, or that means we are choosing the lower pixel, or we are choosing the top pixel, that means x increments all the time, but y also increments. So either you choose 3 2 or 3 3, because you are at 2 3, because you are at 2 3 here. In this case, if you see, you are at 2 3, okay, this is for the what is the x of it, 2, what is the y of it, 3. So you are at 2 of 3. So either you choose this pixel which is x is incremented to 3 and y is not incremented, that is 3 only, y is also 3, or you choose this pixel where x is incremented to 3 and y is also incremented, and 3 plus 1 is 4, so 3 4, if this is a scenario. Okay, uh, now you have to adjust this here about, if that means for this case, if I say, if you say 3 2, that means we were at 2 2. This is what this depicts, that means we were at 2 2. Okay, so if we have the line, which this is the x of k, it is 2 from this side and 2 from this side. Now should I choose this pixel or should I choose this pixel? If it is going between the pixels, say for example center pixels, this is the exact y, and this one is y plus y of k plus 1. This is your y of k, and the y of k is 2, x of k is 2. Okay, let me make it clearly, because this is showing 3 2, so that is why. New slide. So what I am telling you is like this. Okay, if it is going like this, I was here and now I have to choose next pixel. Should I choose this pixel or should I choose this pixel? Okay, so this is your x of k and this is your y of k. Say y of k was 2, x of k was also 2. So next, if it is 2, the next will be 3. So that means this point is at 3. If this is 2, the next y will be 3. So that means you are at 2 2. Now you have to choose whether you x will increment to 3 all the time for both pixels, for this pixel and this pixel. So should you go for 3 and y still remains 2, it was 2 so still remains 2, or you go to the 3 3. Okay, you are incrementing x as well as y. This is what we have here, 3 3 and 3 2. So the y coordinate at the pixel position, if you want to exactly see what is the y, that point, okay, that is, we can get it from the slope, okay, which is equal to m times x of k plus 1 plus b. That means what is the y of the x of k plus 1? That is my, if I want to see what is y at the x of k plus 1, when it is x of k plus 1 of my the slope, that is this one, the slope is here, and this is my x of k plus 1, and I want to find this exact point here, this y here, exactly on the line. Now that will be equal to slope into x of k plus 1 plus, we know that b or c, whatever you like to say, which is your constant. So this is my y, exact y, that is m of x of k plus 1 plus b. Okay, and what is b? That is the x-intercept. Basically b is the y-intercept, not the x-intercept. That is, if we have, say for example, this is my line, and if I produce it, and where will it reach to this y-axis when x is 0, okay, at 0x, where it touches the y, that is your y-intercept, and this is your this b, okay. Okay, so this is the we are here talking about that how will we calculate the y at x of k plus 1, because we have moved to the next point, okay, because uh, we were here, okay, this is the line going, we were here, now we have to draw the next point. So should we do this and this? So if this point was x of k and next point is x of k plus 1, at x of k plus 1, what will be my y? So that will be again used by the line formula, because I have to calculate the slope, that is m of x plus b, and x now is x of k plus 1 plus b. So this is my equation for the y, okay. Let me delete this slide now, I don't need this. Okay, now basically what I'm trying to do is I want basically d1 minus d2. What I want is d1 minus d2. But why the heck I need d1 minus d2? Because I need to see which this line, this is the exact y, okay? This green point is the y. Is it closer to the top pixel center or lower pixel center? So d1, if the d1 is bigger, okay, then this value will come as positive. So if d1 minus d2 comes positive, okay, then I will pixel I will use the top pixel, because that means d1 is greater, this distance is greater, that means it's far away from this pixel and it's closer to the top pixel, so I should uh, color the top pixel. If this comes negative, when will come negative? When d2 is bigger and d1 is smaller, so it will become negative. So if this comes negative, d1 minus d2, I will say, oh no, I should use this pixel rather than this pixel. That means I should increment the x but not the y. Y will stay as yk. So if it comes positive, that means I have to use top pixel. That means I have to increment x as well as the y. Okay. So what is my d1? If I say what is my d1, now this point is the exact y. Okay, this point is exact y. So what is this d1 and what is this point? This point is in terms of y, it is y of k. Okay, and for this guy, what is this one in terms of y? This is y of k plus 1. This is y of k plus 1. So if this was y of k, so that means that this is y of k plus 1. So that means if the y was here 2, it is going to be 3. Simple. अगर ये 2 था, ये 3 बनेगा. So that means अगर मैं इसको बोलूँगा अब ये y of k है, the next will be y of k plus 1. So that means it will be 3. So इसके लिए नेक्स्ट पिक्सल होगा ना, अगर ये हमारा एक इसका y था. इसी तरह से अगर ये x इसका है, x of k, what will be the next x? x of k plus 1. यानी कि अगर ये 2 था तो ये 3 होगा. Simple. अगर x of k 2 है तो x of k plus 1 3 होगा. Simple as it is, right? Okay. Now what I am saying is, now how is I am saying d1 is equal to y minus y of k? Because I want to find this distance and I know this point is y. Okay, exact point on the line is a y. So I will subtract this y by this point. That means then I will get this line, okay, this much. Because say if I'm here to here and I'm already know this is 2 and this is 10. So how much is this one? This is 8. How we calculate this is 8? 10 minus 2. That is 8. So same we do here. If this is y and I know this is y of k, so what will be d1 equal to? d1 will be equal to y, this y, minus this, what is this y here, that is y of k. So y minus y of k, that is this much of distance. So that is my d1. Thus d1 will be y minus y of k. So what will be d2? d2 will be what is here. What is here? What is y here? Y here is, because here the y was y of k, the next step is y of k plus 1. So for this guy, as you can see here y is y of k plus 1. So if you want to find d2, you have to subtract this point and this we know is already y, and this one is y of k plus 1. So that means d2 will be y of, because for this y is y of k plus 1 and this is y, so minus y of k plus 1 with the y, so y of k plus 1 minus y, that is my d2. So I got now d1 and I got d2. So d1, that means y, this is my y, okay, I'm repeating it, this is my y minus what is here y, that is y of k. So y minus y of k, that is d1. What will be d2? uh, d2 will be whatever the y here is, the y here is incremented y, that is y of k plus 1 minus y. Okay, so this is, so now what should I calculate? I should calculate d1 minus d2 because I have to calculate the formula which will give me what is d1 minus d2. So I have to calculate. Now I can't say like orally what is d2 and what is d1. I need a formula. That is I'm trying to calculate. So by that I will calculate the decision variable, upon which if the decision variable is positive, or I take the bottom one, or if it is negative, okay, if it is positive I will take the top one, if it is negative I will take the bottom one, and so on. We'll discuss that later. So I need a decision variable which actually gives me d1 minus d2. So my next step will be to calculate d1 minus d2, but I remember what is d1 and what is d2. So as you could see here, so d1 is y minus yk, okay, which we just calculated from here. So d1 is y minus yk. Now what is y? We have already seen y is, because at this point we are talking about the y at this point, okay, when x is x of k plus 1, at that moment of time, what will be the y? Y will be given by the equation that is y equals to m slope into x plus uh, the y-intercept. But now x is not x, is x plus 1, because x here is x plus 1, x of k plus 1, okay. So I can substitute for this y this value, right? Okay, so let me try to do that in my next slide. So I am using from this equation whatever the y value is into this y, okay. So when I put it into this y, it becomes m into x of k plus 1, this one, plus b. So I am getting, substituting this whole thing instead of this y, and then there is minus y of k, and that stays here like that, y minus y of k. Okay, so I got it from equation 1, and now I call this as equation 2, which is my d1. Same I do with the d2. Same I do with the d2. So what is d2 equal to? D2 is equal to y of k plus 1. I don't touch it, but I know what is my y. Y is the same which I just put in for the d1. Okay, y is same here, that is m of x of k plus 1 plus b. That means what I am doing is, once again, for d2, okay, that is y of k plus 1 minus y. We have seen it, how we got it. Instead of this y, I use this whole thing, okay. So I am substituting this y with the m of x k plus 1 plus b, that is here, okay, and subtracting it, this minus here. Now this is whole minus. Now you have to give minus to this and also to the plus. Now minus, when you give to this, it becomes minus m of x of k plus 1, then minus, and this plus becomes minus b, okay. Now this becomes minus plus minus b. This is my equation third. But what I need to do, I need to calculate d1 minus d2. Why I'm doing d1 minus d2? Because I know if it comes positive and if it comes negative, I understand who is bigger. Is d1 bigger or d2 bigger? If d2 is bigger, then I should choose the downwards, the bottom pixel. If the d1 is bigger, then I should choose the top pixel. Simple as it is. Now, so I will do d1 minus d. So this is my d1, okay. Now this is my d1, and here equation third is my d2. So let me do d1, that is m of x of k plus 1 plus b minus y of k, that is here in a green, and this blue is my d2. So this blue is here, and I minus it, that this minus is here, right? Rather I should have used appearances here to separate. This is the minus, okay, uh, with this thing, okay. Now I give this minus to it, So this stays like this, m of x of k plus 1 plus b minus y of k. It stays like that, whatever it is on this step. But this minus, it makes it y of k plus 1, but minus. Okay, so minus minus is plus, m of x of k plus 1, and minus this is plus b, right? Right. Now I give this minus to this thing. Okay, I am trying to give this minus, this minus sign to y of k and plus 1. So minus into y of k is minus y of k, minus plus is minus 1. Now I am seeing m of xk plus 1 is here, m of xk plus 1 is here, so it becomes twice m of xk plus 1. Now this minus yk is here, minus yk is here, it becomes twice minus yk. This plus b is here and plus b is here, it becomes twice plus b, as you could see here. And the negative 1 is here, so that is negative 1. So that means these guys were twice. This was twice, so I got it minus twice m times x of k plus 1. Okay, now this y of k is twice, so negative y of k, b is twice, and 1 is 1 times. This is equation 4. That is my d1 minus d2. Okay, I go to the next slide to get going. Now if I come back to it, and I am seeing one problem in this, still one problem. I thought that I got my d1 minus d2, this is my formula, but the problem is with this m. I am getting this m. What is the problem with the m? Can anyone tell me? Because what is the slope m equal to? That is delta y divided by delta x. So isn't it dividing? Isn't it getting the floats and all, again the points and all? It's still getting points, it's still getting floats. Then the whole idea of the Bresenham will go into the vein. So I cannot use this m like that. I have to simplify it. I have to get rid of this denominator so that there will be no division, right? So that is why we move further into it. Let me do this of my own. Let me actually delete this thing for a while to get you, so they understand properly what is going on. So what I am here doing is, I'll use the black pen. Okay, what I am doing here is using this m, I am putting it dy by dx. The difference, because we know slope m, we know slope m is equal dy divided by dx, right? Now I'm using the dy by dx, but it's getting again a problem. So maybe I just remove this also, so that 1 second, so that I use the pen only. There. So what I am doing is I'm saying this d1 minus d2, this d1 minus d2 equals to twice, and m I know is a slope, that is dy by dx. So I'm putting up here dy divided by dx, okay, 2 times that thing. And then internally we got a x of k plus 1 minus twice y of k plus twice b minus 1. It's same, I'm not changing it. But the problem is with this dx. So what should I do to remove this dx? So I can get it common. Okay, when you get it common, then you have to give each and every term this delta x. Or simply you can do what? You can multiply d of x on both sides. Okay, when you multiply delta x on both sides, that will also remove in a denominator. That's what I'm doing, is I will multiply d of x here to this side, and also multiply d of x to the whole of this side. Because if, say for example, this is 2 equals to 3x plus 4, for example, and there is here divided by 6, and you want to remove this 6, so you can multiply 6 on this side and multiply it with this 6 on this side. So then 6 and 6 will cancel, and but it doesn't matter because you have multiplied 6 on both sides. So say on this side it was 3 equals to 3, so if you multiply 6 on this side, you multiply 6 on this side, 6 3 is 18, 6 3 is 18, so 6 times 3 is 18, so it doesn't matter because you're multiplying it on both sides, right? So that is how I can do it, remove it. Simple thing is actually to get the d of x common, and then you have to multiply it everywhere. But if that seems complex, then what you do is you multiply d of x on a difference of x on both sides. Now here what it becomes d of x, d of 1 minus d of 2 is equal to, now this d of x then get multiplied to each and every term. Here d of x and d of x cancels out, becomes twice d of y. Okay, now and then with it is the x of k plus 1 for this term. This is the complete term, x of k is a subscript. Okay, minus, now you have to give dx to multiply to this, so it becomes twice delta d of x y of k, multiply this d of x to this twice b also. Okay, so this becomes twice what is d of x and b, then multiply d of x with this one and becomes minus d of x, right? It becomes minus d of x. So what I'm doing here is I'm multiplying it with every one d of x, because I want to remove d of x in the denominator. Why? Because I don't want it in a division. I don't want division operator, because division operator can generate points, so I do not want that. So that is what I'm doing. I'm multiplying both sides the d of x so that I remove the denominator and get it in the numerators. Okay, simple. Or you could directly do it, you remove it in a denominator in this term, then you have to multiply it with everybody, because you are removing it in a denominator, so you have to multiply it with everybody other than this term, right? Or you can do this way, or you can multiply both sides the d of x, so d of x and d of x cancels out, d of x multiply by this 2yk is twice d of x yk, and d of x multiply with 2b is twice d of x b, and d of x multiply 1 is d of x. Okay, now I clear this clutter and get it back what we had. Somehow it's not getting undo, so I have to keep it like this. So let me write it with the hand now here. Okay, equals to, where it's not writing, 1 second, equals to, now I multiply this twice d of y with the k, with the x of k, so this becomes twice d of y x of k, and plus this twice d of y into 1 is twice d of y, and rest of it remains same, this whole thing remains same, that is minus twice d of x y of k plus twice d of x times b minus d of x, right? Now if you could see here, these terms which I put on with the highlighter, this twice d of y, this twice d of x, okay, um, with multiply with the b, and this minus d of x. Now these are the constant terms. So these are constant terms, because what is d of y? That's y2 minus y1. It all the time is same. What is the d of x? Again, it's x2 minus x1. That is all the time same. This is a constant term, and b is also constant. So d of x is constant. So these are constant, which I marked in the with the highlighter. So that means, because I'm trying to decide something, okay, so decision will be on the variables, not on the constants, because constants remain same for everybody. Okay, now this is the d of y times x of k, and this is d of x times y of k. Now these are now these are the decision variables, because here the x of k will be different all the time, y of k will be different all the time, because for each and every pixel y of k will be different. According to that y of k and x of k, we can have our decision variables. So that means what I have done is I am saying this is d of x, as you could see here. I'm calling this whole thing, if I rearrange this, okay, I will rearrange it here. 1 second, I will clear the clutter on the down. Let me pause. Now what I do, escape and get this to the down. Okay, and here what I am doing is let me write it with the red now. So now I got a d of x into d of 1 minus d of 2 equals to, now this one, this term which is required twice d of uh, y x of k, that is this term here, and this term minus twice d of x and y of k. Okay, and the rest of these three terms which I highlighted, I call it as c, the constant, because I want to take a decision. When you want to take decision, you do not want the decision can't be on a constant, because constant will be all the time same. So it doesn't contribute to the decision. These contribute to the decision, so I can simply eliminate it. So my decision variable, which is I call this thing, this red thing, as a decision variable dv, or in this case we have called it pk. Okay, now the pk is my decision variable, and this constant c, which is equal to 2 dy plus these highlighted dx of b and d of x, so that thing, okay, is a constant. So I do not take that into account, these constant. And why it is saying d of x 2b minus 1, so that means it has not given multiplied this to each both of these. This is multiplied only to the twice b. Rather we should say properly here that this is equal to twice d of y plus twice d of x. I should cut it, then yk plus twice d of x b minus d of x. Okay, actually twice d of y, then twice d of x yk, uh, not twice d of yk. Let me erase this, because this thing can't be in a c. Okay, this one is in a c, twice d of xb minus this little mistake, so twice d of y plus twice d of xb and minus d of x. This is my constant c. It has nothing to do with the nothing to do with my decision making, so I should simply eliminate it in my decision variable. So my decision variable only is this much. Okay, that is my twice d of y xk, that is this term, and twice d of x yk, that is this term. And this c, I can eliminate it. It is not in my decision variable, okay, because it doesn't matter. So what I do is I simply say here escape, and I just remove this term, because this term can be removed easily, because I don't need this in my decision variable. So my decision variable is only equal to twice d of y, what are my d of x and d of y's are, okay, multiplied with the xk and multiplied with the yk. So whatever, so in my program, when I try to calculate this decision variable, what shall I do? I will calculate my d of x and d of y. So when I calculate my d of x and uh, okay, let me change the color of it. Black. I will use the d of x, calculate d of x like I calculate DD algorithm. I calculate d of y, okay, and I multiply d of x with y of k, and multiply d of y with x of k. Now, and then minus them together, and this will give me uh, d of y x of k minus d of x y of k. So this is to be minus with this one, and this will give me the decision variable. Okay, now how should I proceed with this thing? Now the decision variable, how we do that is we say how we take a decision, actually I mean to say, is if this p of k coming positive, that means d of 1 minus d of 2 is actually coming positive. So what does that mean? It comes positive. When it comes positive, that means d of 1 is greater than d of 2, so that means I should take the top pixel. And if it is coming negative, because d of 1 minus d of 2, that is my decision variable p of k, if it is coming negative, so when it will come negative, when the d of 2 is bigger. So d of 2 is bigger, that means this line is far away from this pixel and closer to this pixel, so I should take the bottom one, right? So this is what I do in the program. I will chuck my decision variable. Now I was here, this was my x of k and y of k, right? And I was trying to take decision on the next pixel. Should I take this pixel or should I take this pixel? Now after that I have to use another decision for this pixel. Should I choose this pixel or should I choose this pixel? X will go on increasing. Now this will become x of k and y of k, whatever I have chosen, this one or this one. Now they will stay as whatever their x and y k is for this pixel now, okay, which is next pixel to be chosen. So this decision is to be taken at each and every pixel, the next pixel. So that means now I have to choose the p of k plus 1. That means I have to choose the decision for the next variable, next point. Should I take this pixel or the top pixel? So this decision for y is to be taken while plotting each and every pixel, right? Like we had the pixels here. So I am, should I choose this pixel or this pixel? Decision is to be taken. So this p of k will chuck the p of k. Then we move on to this one. So should I take this pixel or this pixel? Okay. Again, a decision has to be taken. The next goes on. Should I take this pixel or should I take this pixel? The decision is to be taken all the time. Okay. So firstly, we are saying that this c is a constant and is independent of the pixel position. So it can be deleted in the recursive calculation. So it doesn't contribute on a decision of p of k. So this is our p of k, and k has to be in a subscript, not in a, that means the decision variable p at the kth location, because we were doing on the kth location this one. That means what I was doing here, okay, on this location I'm talking on the kth location, the decision that should I take this pixel or this pixel. Now the next pixel will be k plus 1, so I have to also take decision at p of k plus 1, right? Now here I remove the c and I have to choose the p of k, and if d1 is less than d2, okay, that means yk is nearer to the line path, that is if d1 is less, d2 is more. So simple as it is, if d1 is less, that means y of k, that means bottom pixel is near to the line, okay, then what will be p of k? Will it be negative or positive? Because d of 1 is lesser than d of 2, so d1 minus d2 get us negative value. So because this is lesser than d2, so we get negative value. We get negative value, we choose the lower pixel, okay, that is y of k is plotted. Else we choose the upper pixel, that means d2 is bigger, that means this p of k is positive. So if it is positive, then we should take y of k plus 1, that is the top pixel. Now at k plus 1 step, now we have to move the further to the next step. What will be the value of p of k? Okay, the value of p of k will be, because we had here in the previous example, what was the p of k? P of k was twice d of y x of k, twice d of x y of k. Now what will be p of k plus 1? The p of k plus 1 will be twice d of y x k plus 1, twice d of x y k plus 1. So that is here. So this is my p of k plus 1 will be, at the x use x of k plus 1 and y k of plus 1 plus the c, and or you can eliminate this c because it's not used for our decision making. Okay, so calculate the next p of k. What we do actually is we do p of k plus 1 minus the calculated p of k. Okay, let me go to the screen draw. This is my p of k plus 1, this is minus p of k. This is what you do to calculate the next decision variable. So we do it what the p of k plus 1 actually is twice d of y x k plus 1 and minus twice d of x into y of k plus 1 plus c. This is the old this is the, in the previous slide we did it, minus the p of k which we calculated originally, that is here it was xk of plus k plus 1 for the p of k plus 1, but for p of k it is just x of k and y of k. We had done it. Now here twice d of y is here, and is also 2 of d of y here. I'll get it common, and here inside will stay as x of k plus 1 and this x of k, so that is x of k plus 1, and then this minus sign and x of k, then the minus sign here, and this twice d of x and this twice d of x will come common here, and it will stay here as y of k plus 1, that is here, and y of k, that is here, and with the minus sign, and right, and c minus c simply cuts out, cancels out, so there's no need of using this. So you could simply remove it beforehand because the constants are not required in the decision, or this will gets cancelled out here in this equation. So we get the equation 7, which is about p of k plus 1 minus p of k. And now you get the p of k on this side maybe to get the things, but before that I could say that if for the if we talk about the lines which are less than 45 degree, we know x of k plus 1, that is the next x, it's like in a loop, which is the next x, uh, that is actually equal to incrementing it with 1, because if for this point it was 2, for the next point it has to be 3, so it is 2 plus 1. So that means if this was x of k, right, now, and this 3 is x of k plus 1. Now this x of k plus 1 is nothing but whatever is x of k, that is 2 plus 1. That means this x of k plus 1, that means what is next x? It will be what is the previous x, that is x of k plus 1 on the top, not plus 1 to the on the bottom. So plus 1 in the bottom means what is the next x, and the next x is nothing but what was the previous x, x of k plus 1. So you can use x of k subscript k plus 1 is equal to x of k, that is previous what was the x of k plus 1, because it all the time increments x. So you can use this here in this equation where there is the x of k plus 1. You can say x of k plus, not subscript but plus 1, because we know what is the previous x of k, it has to increment 1, right, rest remains same. Now here this x of k and minus x of k cancels out, and there is plus 1 here only, and d of twice d of y into 1, that is twice d of y. So this whole thing comes out to be twice once again let me erase this. No, this is screen actually. Yeah, so this whole thing comes to be equal to, because this x of k gone, this is twice d of y into 1 is twice d of y, and from this side it stays like that, whatever it is. Okay, now I get this minus p of k on this side. Okay, I get a p of k, so that I get exactly what is my p of k plus 1, that is what is the decision variable, the next decision, I could say p of k of next. That means what is the next decision variable, that is whatever the previous decision variable was, plus twice d of y minus twice d of x, and y of k plus 1 minus y of k. Now this y of k plus 1 and y of k, it can be either 0 or 1. Why? Because if you were here it was, the k was 2. If you choose this pixel and this pixel, if you choose this pixel, the k will the y of k plus 1 stays as what the y of k was. That means for this one, the y of k, this is y of k, let me make it a little bigger again. Okay, let me make it a little bigger to make you understand. This is my point, and should I take this point or should I take this point, because the line is going in between, right? Now this is my x of k, y of k. Now I'm talking only of y of k right now, so this is my y of k, and for this one this is y of k plus 1. Now if I chose the next y, okay, as the same as the previous one, that means it is y of k only, or if I choose this one, then this becomes y of k plus 1. Okay, so that means y of k plus 1, that means what is my next y, is it same as the previous one, then this will become y of k only, then y of k minus y of k, that is 0, it will become 0. Or if I chose the next one, then it's y of k plus 1 minus y of k, then it will have a difference of 1, because if it is say at 4, location 4, what will be the next, that will be 5. So I'm saying y of k plus 1 minus y of k, that means 5 minus 4, that is equal to 1. So this will come either 1 or 0. So if I have not chosen I have chosen the below pixel, that means I am not incrementing the y of k stays same. So that means next y, that is y of k plus 1, will stay same, say it was at 4, and which y of k was 4, so y of k plus 1 is also 4, so 4 minus 4 is 0. Or if I have incremented 1, then y of k plus 1 is actually basically there is difference between saying y of k plus 1 and y of k plus 1. There is a difference in saying that. Y of k plus 1 is what is next y. Okay, y of k plus 1 and in a top one means whatever is the previous y of k, add that one. That means if it was 4, make it 5. Okay, and this 5 is y because this was y of k was 4 and I added this thing to the 1. So what is y of k? I added this 1. And this 5 is nothing but y of k plus 1. That means next y. Right? Right. Now that means this y of k plus 1 or this y of k either becomes 0 if I have chosen the same y of k, it becomes then 0, or if I incremented, then it becomes 1. So it can come 0 or 1, and it depends on the sign of the pk. So when we make it 0 or 1, we shall chosen we know at the p of k, that means we have taken a decision here. Once again, we have taken a decision here. For example, if my p of k comes negative, okay, when p of k come negative, that means d1 minus d2 is negative. That means d1 is lesser. So that means I have to choose here the lower pixel, so if it is negative. So that means, in other words, if you give me 1 second to erase this. Now if I talk in terms of, because I know this is all the time d1 minus d2, but basically I'm talking in terms of p of k, that's decision variable at this. So if it is, I'm at k is this one, so this is x of k, y of k, and I have to choose whether I have to use this pixel, then x of k all the time increments, but y of k does not increment. But here y of k increments, okay, and x of k also increments. So that means whatever the x of k was, the previous x was, okay, it becomes plus 1 to that. So if it was say at x2 and y was also say for example 2, so this becomes y of k plus 1. Y of k is 2, 2 plus 1 is 3, so it has gone to the 3. Now here on this side it's become x of k plus 1. That's what is x of k? 2, 2 plus 1 is 3. But y of k stays whatever the y of k was, the previous y was, that is 2, it stays at 2. Okay, so when will I choose the bottom pixel? At this moment when I'm taking decision, if p of k comes negative. If a p of k comes negative, I do not increment. So that thing is that if p of k comes negative, I do not increment y, I take the bottom pixel. If p of k comes positive, I take the top pixel, I have to increment. Now I'm telling about the next decision, that is now I have to take decision for the next pixel, which is gonna be here. Should I take this pixel or should I take this pixel, and so on. Should I take this pixel or the bottom pixel? So that will be the next decision which I need to take. So that is what I am saying here, is that firstly, if p of k was say for example negative, then y of k plus 1 is same as y of k, so it becomes 0. So 0 into twice d of x, it's gone. So the whole thing will be, the p of k plus 1 will be just p of k plus twice d of y. Okay, but if it was positive, p of k was positive, that means the y of k plus 1 which I have taken is actually y of k plus 1 minus y of k, that the difference will be 1 all the time, so it will come as 1. So now this will evaluate to 1, so it will be p of k plus d of y minus 2 d of x. So what I am saying is like this, that if p of k is less than 0, the next point to plot is x of k plus 1 and y stays as y of k. So y doesn't increment. So when y doesn't increment, then in this formula, this y of k plus 1 is replaced by y of k because it's same. It's not y of k plus 1 is same as the previous, that is y of k. So it becomes like y of k minus y of k. So they cancel out to 0. 0 into twice d of x is 0. So it stays at this one, p of k plus d of y. So it stays at p of k plus twice d of y. You should write actually the delta y, okay, like that. Now if p of k is coming greater than 0, that means here this y of k plus 1 is incremented. So the difference between the two will be 1, because if the y of k was 2, it has incremented to 3. It has gone up 1. So that means 3 minus 2 is 1. So this one, the difference of this comes 1. So 1 twice d of x is d of x. So now this time it will be p of k plus d of y minus twice d of x. Okay, you can say d of y and twice d of x, because that thing come out to be the 1, that y of k plus 1 minus y of k, that come to be 1, right? And the initial parameter, that is in the beginning, how we choose the decision variable p of 0, that is simply twice d of y minus d of x. So don't use the other terms with it, because it's a p of 0, that's initial value. The initial value, when you start your algorithm, you will make p of 0 as twice d of y minus d of x. I think the video is getting bigger. It's getting more than 1 hour. That is kind of boring for you guys. You can watch it in a double X speed, put it on the copy, and put these all things in a copy, make it in one page, and you will be all good. It took time to make you understand, but it's easy if you just go through it. Okay, see you in the next vid. Until then, ma salama.